In this problem, we're going to calculate the radius of a calcium atom, knowing that it forms a face-centered cubic cell and that it has a density of 1.54 grams per mil. As we can see in the overlay up here, each unit cell has 4 atoms. There's 1/8 of an atom in each of the 8 corners, and then there's a half of an atom in each of the 6 faces. So if we look down the diagonal C of the overlay, we can see that that covers 4 radii. That is, there's one radii going through each of the corner atoms, and then 2 radii going through the atom that's in the middle of the face. So our objective is to calculate C and then realize that the radius is 1/4 of C. Okay, so we follow the same technique that we've done all along. That is, the first step is calculate the volume of the unit cell. The second step, once we know the volume, is to calculate the length of the unit cell. Once we know the length, we need to calculate the diagonal across a face. That is, and we need to know that the radius is equal to the diagonal divided by 4. That is, C is 4R. Okay? So let's first calculate the volume. For a face-centered cubic cell, there are 4 atoms of calcium per unit cell. If it was a simple cubic cell, there would be 1 atom, and if it was a body-centered, there would be 2. Now, we know that there are 6.022 times 10 to the 23rd atoms per mole of calcium. And we know that calcium, if we go to the periodic table, has a molar mass of 40.08 grams per mole. So this has told us how many moles are in a unit cell. The atoms cancel. And I can now go 40.08 grams of calcium per mole. The moles cancel. And I now know how many grams there are in a unit cell. Now, the density allows me to go from mass to volume, but I need to divide by the density to get rid of grams. So I have the density of calcium is 1.54 grams per milliliter of calcium. Okay, remember a milliliter is a centimeter cubed. And I bring out my calculator, and I get 1.73 times 10 to the minus 22 milliliters. Okay? Now I want to convert this to length, okay? And so I can now say that for a cubic cell, the volume is equal to the length cubed. Therefore, the length is equal to the cube root of the volume, which is equal to the cube root of 1.73 times 10 to the minus 22. And I'm going to write this as centimeters cubed. Okay? And what I usually do is I take this to the power of 0.3333 because it's faster on the calculator. And because the cube root is 1/3, the power of 1/3, and 1/3 is 0.3333. And I get out my calculator and I get 5.57 times 10 to the minus 8 centimeters. Now, centimeters are a macroscopic measurement of value on our scale, and atoms are much smaller. And so we typically describe lengths of atoms in terms of angstrom, where an angstrom is 10 to the minus 10 meters. And note, you should know that a centimeter is 10 to the minus 2 meters. So I can say that 1 meter is 10 to the 10th times 10 to the minus 10. So 10 to the 10th angstroms is 1 meter, and 10 squared centimeters is a meter. That is, 10 squared is 100, centimeters is 100th, so 100 hundredths is 1. So I can convert this to angstroms very quickly by saying that 10 to the 10 times 10 to the minus 10 is 1, but 10 to the minus 10 is an angstrom. And I can divide by 10 squared times 10 to the minus 2, which is a centimeter. I hope you all understand what I'm doing. This is saying 100 hundredths, which is 1. So this gives us 5.57 angstroms, okay? Now that we know the length of the cubic cell, we need to calculate the diagonal C. Now, and we're going to call this A in our diagram, okay? That's the length of the cubic cell. So I can say that C squared equals A squared plus A squared from the Pythagorean theorem. So C is equal to the square root of 2A squared, which is equal to the square root of 2 times 5.57 angstrom squared, which is equal to 7.87 angstroms. So that is our value for C, okay? Now, we know that R is C over 4, so R is equal to 7.87 over 4, which is equal to 1.97 angstroms. And so now we've been able to calculate the radius of a calcium ion by knowing that it formed a face-centered cubic cell and it had a density of 1.54 grams per milliliter. Okay, I hope that helps.